Welcome to the presentation on operating systems concepts. Today, we will explore the fundamental aspects of operating systems and their importance in computing. An operating system is a crucial program that acts as an interface between the user and the computer hardware. It controls the execution of all kinds of programs, ensuring smooth operation and resource management. The primary goals of an operating system are to execute user programs efficiently, make the computer system convenient to use, and utilize the computer hardware in an efficient manner. An operating system serves as a resource allocator, managing all resources and deciding between conflicting requests. It also functions as a control program, preventing errors and improper use of the computer. The kernel is the core program running at all times. Operating systems are the most important software on a computer. They manage memory and processes, handle software and hardware, and allow communication with the computer. Without an operating system, a computer is useless. Learning about operating systems is essential as they perform critical tasks such as file management, memory management, process management, handling input and output, and controlling peripheral devices. Some popular operating systems include Linux, Windows, Mac OS, and VMS. Each has its unique features and is used in different environments and applications. A computer system is divided into four components: hardware, operating system, application programs, and users. Each component plays a vital role in the overall functionality of the system. This diagram illustrates the structure of a computer system, showing the interaction between users, system and application programs, the operating system, and computer hardware. In a computer system, CPUs and device controllers connect through a common bus, providing access to shared memory. This allows for concurrent execution of CPUs and devices competing for memory cycles. I/O devices and the CPU can execute concurrently. Each device controller manages a local buffer, temporarily storing data, while the CPU moves data between main memory and these local buffers. Interrupts are signals sent to the CPU by external devices to stop current activities and execute the operating system's instructions. Device controllers inform the CPU of completed operations by causing an interrupt. Interrupts transfer control to the interrupt service routine via the interrupt vector. Traps or exceptions are software-generated interrupts caused by errors or user requests. Operating systems are interrupt-driven. Computer storage starts with the bit, the smallest unit of data, and includes bytes and words. A byte is 8 bits, and a word is a group of bytes. Computers execute many operations in their native word size. Storage and throughput are measured in bytes and collections of bytes, such as kilobytes, megabytes, gigabytes, terabytes, and petabytes. Manufacturers often round off these numbers for simplicity. Main memory is the only large storage media directly accessible by the CPU. Secondary storage, like hard disks and solid-state disks, provides large non-volatile storage capacity. Storage systems are organized in a hierarchy based on speed, cost, and volatility. Caching involves copying information into faster storage systems, and device drivers manage I/O operations. Cache memory increases data access speed by storing frequently used data. Data required for processes resides in the main memory and is transferred to the cache if used often enough. Device drivers enable hardware devices to communicate with the operating system. Without drivers, computers cannot correctly send and receive data to hardware devices like printers. This diagram shows the hierarchy of storage devices, from registers and cache to main memory, solid-state disks, hard disks, optical disks, and magnetic tapes. A general-purpose processor operating system is designed for general-purpose computers like PCs or workstations. Most systems use a single general-purpose processor, where the main concern is the computation speed. However, these processors are not designed for fast real-time applications. A multiprocessor operating system uses two or more central processing units within a single computer system. These multiple CPUs communicate closely, sharing the computer bus, memory, and other peripheral devices. Multiprocessor operating systems, also known as parallel or tightly coupled systems, offer increased throughput and reliability through fault tolerance. There are two types: asymmetric multiprocessing, where each processor is assigned a specific task, and symmetric multiprocessing, where each processor performs all tasks. Symmetric multiprocessing involves multiple CPUs sharing memory and tasks equally, while asymmetric multiprocessing assigns specific tasks to each processor, with a master-slave relationship and no shared memory. A dual-core processor is a CPU with two processors or execution cores in the same integrated circuit. Each processor has its own cache and controller, enabling it to function as efficiently as a single processor. Clustered operating systems resemble parallel operating systems as they possess multiple CPUs. A cluster is created when two or more computer systems are merged, sharing common storage and working together, usually via a storage area network. Operating systems have various properties, including batch processing, multitasking, multiprogramming, real-time systems, and distributed environments. Batch processing is a technique where the operating system collects programs and data into a batch before processing starts. This method reduces idle time, manages large repeated work easily, and takes much of the work off the operator. Multitasking allows multiple jobs to be executed by the CPU simultaneously by switching between them frequently. This enables users to interact with each program while it is running. Examples include Linux and Windows 8/10. Multiprogramming involves sharing the processor among two or more programs in memory at the same time. Only one program gets the CPU at a time, while others wait their turn. This increases CPU utilization by organizing jobs so the CPU always has one to execute. Multiprogramming offers high and efficient CPU utilization, making users feel that many programs are allotted CPU almost simultaneously. Real-time systems are usually dedicated, embedded systems. The operating system reads from and reacts to sensor data, guaranteeing responses to events within fixed periods to ensure correct performance. A distributed environment involves multiple independent CPUs or processors in a computer system. The operating system distributes computation logic among several physical processors, managing communication between them through various communication lines. An operating system has several important functions, including memory management, processor management, device management, file management, security, control over system performance, job accounting, and error detecting aids. Main memory provides fast storage accessed directly by the CPU. To execute a program, all or part of the instructions and data must be in memory. Memory management determines what is in memory and when. The operating system keeps track of primary memory, deciding which process gets memory and when, allocating memory when requested, and allocating it when no longer needed or terminated. In a multi-programming environment, the operating system decides which process gets the processor, when, and for how much time through process scheduling. It keeps track of the processor and status, allocates the CPU to a process, and allocates it when no longer required. The operating system manages device communication via drivers, keeping track of all devices, deciding which process gets the device and for how long, allocating devices efficiently, and allocating them when no longer needed. A file system is organized into directories for easy navigation and usage. The operating system keeps track of information, decides who gets resources, allocates them, and allocates them when no longer needed.